In this video, we're going to solve some questions on how you find the maximum and the minimum value of a function. So basically, these are some of the questions. So the minimum and the maximum value of a function is just the same as the turning point. Okay, so let's start with the first question. Now you can solve this using calculus. You can also solve it using completing the square, which we are mostly familiar with. You can watch our videos on how you solve using completing the square. Okay, however, there's another formula that you can use, which is x. If you're finding the value of x at the turning point, it is negative b over 2a. Then from here, you're just supposed to replace. That would be negative. B is a coefficient of x. In this case, it is a 6. So it is negative 6 over 2. Our a is a coefficient of x squared. That is a 1. Therefore, I'm going to have negative 6 over 2. Negative 6 divided by 2, that is negative 3. So this is the value of x at the turning point. What about y? So for y, we're going to replace the value of x in the whole function. Okay, so therefore we're going to have f of wherever there is x, we're going to be replacing by negative 3. So that would be f of negative 3 is equals to negative 3 squared plus 6 negative 3 plus 5. Then we solve. Negative 3 squared, that gives us a 9. Okay, then minus 6 multiplied by 3, that is 18 plus 5. Okay, 9 minus 18, that is negative 9 plus 5. Negative 5 plus negative 9 plus 5, that will give us a negative 4. So that's a value of y at the so the turning point in this case will be equals to negative 3, which is the value of x, and negative 4, which is the value of y. That's where our graph is going to turn from. So basically, this is how we're going to be doing for all the other questions. However, you can solve it also using completing the square, although maybe a bit it will depend on the route that you want to use, okay, based on how tedious the question is, because sometimes the numbers can be so big that you might not use this formula that we've used. So the way we complete the square, I'm going to say x squared plus 6x plus 5, this is equals to 0. Now I'm now going to find the half of the coefficient of x. Our coefficient of x here is 6. So I'm going to find its half by multiplying by 1 over 2. When I multiply by that, what am I going to have? I'm going to have 2 into 2, that is 1. 2 into 6, that is a 3. I'm just going to remain with a 3. So therefore, we are going to have x squared plus 6x plus this half, okay, the one that we found. We are going to add it and subtract it, but by squaring it. So in this case, I'm going to have 3 squared, okay, minus again 3 squared plus the 5. Okay, now that we got this, we just need to solve. Now what you're now going to do is that this one that we had halved, I'm going to ignore it. Then the ones with the squares, I'm going to put them in one bracket. So I'm going to have x plus 3, this will be squared, minus, now 3 squared here, that will give us a 9 plus a 5 there. So therefore, our final answer, if we're going to solve, we're going to have x plus 3, the square, minus 9 plus 5. In this case, negative 9 plus 5, that will give us a negative 4. Okay, so this is our answer. Why we are saying this is our answer? Because we always want our answer to be in the form of a x plus p squared minus let's say minus or plus q, just like that, plus q. So this is the form that we always want to attain when you are using completing the square. Now what you are able to see now is that for the turning point based on this expression that we've written, the turning point will be equals to negative p comma q. So whatever you have as the p, put a negative in front. In this case, what is our p? From the equation we're able to see that p is here. Even from the one that we're from solving, p is here where 3 is. So we're going to put minus, then we'll put a 3 comma. Q, you're just getting it the way it is. The q in this case, it is our negative 4. So that is negative 4. So that is the turning point. Then verifying that this is equals to that. So depending on the method that you're using, you're going to solve using that. Then how you sketch this one, just find the turning points. We've already found the turning point. Just find the intercepts and you graph. Then you're done. So let's solve the second equation. So we've got x squared plus x minus 6. So what are we going to do? X is equals to negative b over 2a. Then from there, we're just now supposed to solve. So that will be negative. Our b, it is the coefficient of x, which is 1 over 2. Our a is also 1. So we're going to have negative 1 over 2. So that is the value of x at the turning point. Then what about the value of y there? So the value of y, we're going to just replace by what we found as the value of x. That is negative half. That will be equals to, so we're going to have negative half squared plus negative half minus 6. Then we're just supposed to solve this whole expression. Now if I have a square here, so I'll have a negative 1 squared, that will just give me a 1 over 2 squared, that will give me a 4. Then minus 1 over 2 minus 6. Okay, basically that. So let me just solve this equation. So we've got 1 over 4 minus 1 over 2 minus 6. I can put over 1 this side and I find the common denominator, which is 4. 4 into 4, that is a 1. A 1 multiplied by the 1 on top is a 1. Minus 2 into 2, 2 into 4, that is a 2. A 2 multiplied by the 1 on top is a 2. Minus 1 into 4 is 4. 4 multiplied by 6 on top, that is a 24. Then we solve what we have. Now we've got negative 1 minus 2, that is negative 3. Negative 3 minus negative 24, that is negative 27. So we're going to have negative 27 over 4. Is it? Yes. So basically that. So at the turning point, therefore, we're just going to have what are we going to have? Okay, we are going to have what did we find as our x? Our x was negative half, comma negative 27 over 4. So basically that would be our turning point. So let's solve the third question. So that is what we have there. So what are we supposed to have as our x? The same thing, x will be equals to negative b over 2a. We're going to have negative, what is our b? Our b in this case is 5. What is our a? Our a is 2. Then we solve. So we're going to have negative 5 over 4 as the value of x. Then for us to find the value of y, so to be f of negative 5 over 4 will be equals to 2. Wherever there's x, we're going to be replacing negative 5 over 4. So we're going to have negative 5 over 4. This is squared plus 5, negative 5 over 4, then minus 12. Then we just solve this, expression. So the 2 into 2, that is a 1. 2 into 4, that is a 2. So I've got negative 5 over 2. Oh, actually we have a square, so I'm not supposed to forget the square first. So I'm going to have a 2. 5 squared, because I have a square there, 5 squared, in this negative, I'm going to have 25 over 4 squared, that is a 16, plus 5 multiplied by the negative 5, that will give us a negative 25 over 4, then minus 12. Basically that. Now that we got this, we just need to now just solve this expression. So 2 into 2, that is a 1. 2 into 16, that is 8. So I'm going to have 25 over 8 minus 25 over 4 minus 12. Then I just find the common denominator. The common denominator here is 8. 8 into 8, that is 1. 1 multiplied by the 25, we have a 25. Minus 4 into 8, that is 2. 2 multiplied by the 25 on top, that is 100. Is it? Not a 52, that is. Okay, that is a 50. Okay, then minus 1 into 8, that is 8. Then 8 multiplied by 12. So 8 multiplied by 2, that is 16, carry 1. 8 multiplied by 1, that is, okay, so we're going to have 96. Okay, basically that. Then we're going to have over 8. Then we're just supposed to subtract 25 minus 50, that is negative 25, minus 96. Then you solve 8. Okay, so it will be 8 over negative 25 minus 96, that gives us negative 121. So basically that would be the value for y at the turning point. So basically this is how you find the maximum and the minimum of a function, okay, either using completing the square or just normal using the formulas that we've been using. So thank you, and we're going to see you in other sessions.